Hi, welcome to Module 1, Basic Counting Theory. I reckon by now you have already watched that first video of a man trying to get people's password. Well, it seems funny, but if you think about it, why was he trying to actually look at the numbers that people are trying to type rather than guess? Because there may be many possibilities that there's possibly no way of him knowing their passcodes for their bank account unless he secretly tries to watch them, the numbers, the pins that they're trying to enter. So we're going to use that as a basis for our module this time to discuss about counting theory. Now, what methods can we use to try to figure out how many possibilities are there of numbers that can be created, let's say from 10 digits. And we're going to look at problems like this, and later on we'll try to figure out if there's a better mathematical processes that we can use to figure these things out. Now, this will come in very handy later on when we study probability, or when we have to figure out a sample space, or in other words, the number of possibilities. And these are things that are not easy to count, but let's start with some basic counting theory. Now, all of us here are familiar with our iPad. Now, when you want to enter and use your iPad, you need to usually enter a 4-digit passcode, and you are given 10 digits, and you need to create a passcode that you need to enter each time. Now, based on this passcode here, which is 4 digits, as you can see, we need to enter a 4-digit number. Now, can we figure out how many possibilities or numbers that are possible that I can create using this 10 digits? How many passwords can I create? Now, in a similar way, if you look down here, we're pretty used to taking MCQs, and each question has 5 possibilities. Now, assuming that I take a certain number of questions, MCQs, now can I count how many possible ways, assuming that I do not know the answers to these questions? If I were to take a guess, either A, B, C, D, or E, how many possibilities are there given a number of questions? Now, we're going to try to figure out this kind of problems, and to try to understand how we can solve these problems, or find answers to these questions. Now, later on, we will come back to these questions again, and we will try to answer it. Now, let's move on. Let's take a very simple question. For example, a true or false question. Now, you're given a question and you need to answer whether it's true or false. So there are 2 possibilities. Now, if I was given 3 questions, let's say just 3 questions, and I need to figure out how many possible ways can I answer these 3 questions if I do not know the answers to these 3 questions. Now, the first method we'll use is we'll try to let's say we just try to list down, okay, in an orderly manner, the number of possibilities. Let's say the first possibility is true, true, and true. Now, I can keep going down here, and I can start listing down. I can say false, true, true, and then I can say false, false, and true. So there's 3 here. Do pardon my handwriting here, it's a little bit difficult to write down in the pad, but I hope you can see it clearly. Now the second possibility will be the extreme, which is false. The second question is also false, and the third one is also false. Now I can have true, true, false, and I can also have true, false, false. So far I have 6 lists. Now is there any more? Yes, I can have false, true, false, and I can have another one which is true, false, true. Now if I were to count all these things, I will see that I get 8 possibilities that I've been able to list out. True, 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 false, 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 the extremes, false, true, true, false, false, true, false, true, false, true, true, false, true, false, false, true, false, true. Now this assuming it's only for 3 questions. Now I can systematically list down, but the question here is, what if there are more than 3 questions? Now will I be able to systematically list down all the possibilities? Definitely not. So in this case there are 8 possibilities. Now let's move on. Let's use another method, and this time I will try to use a tree diagram. Let's say the first question, I will start with either true or false. Now the second question, if I answer the first question true or false, the second question can also be true or false. Likewise, true or false. Now the third question, there's another possibility, which is true or false, and then true or false, and then I can have true or false, and I can have true or false. Now if I list down all the possibilities down the trees, I get 1, 2, 3, 4, 5, 6, 7, 8. Exactly the same as just now. Okay, so I've used 2 different methods, but I've gotten the same answer. So there are 8 ways I can answer a true or false question in 8 different ways. Now let's try to figure out if there's a pattern here, something that we can use to figure this out. Okay, let's move on. Now we're not going to look at learn about ducks, but as you can see, the ducks are arranged in a row, and we kind of use this same method to figure out the answer to the other question. So what we're going to do is we're going to draw boxes in a row, and then we're going to try to put numbers in here to figure out how we can get the same answer as before. So this is a method that you need to really understand, because a lot of the questions will be answered using this box in a row method. Okay, so given that I have 1, 2, 3 questions, okay, 3 multiple questions, each as true or false. Okay, remember the answer can be true or it can be false. Now the first question, I have 2 ways. Okay, true or false. The second question, I also have 2 ways because the options are still the same. The third question, I again have 2 ways. Now once you have done this, what you got to do is you got to take the first number, multiply with the second number, and then multiply with the third number. 2 times 2 is 4. 4 times 2 is 8. And we get 8 ways. Okay? Now, if we go back, we'll see that we've gotten the same answer, but we have used an easier method. Now, this is called box in a row, and this is a method that we call basic counting theory. So we use this method to find answers to problems that are similar. So going back to this question, let's say, what if now I have 6 questions? Well, it's not a problem, okay? So what I'm going to do is, I'm going to draw a box in a row. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Again, it's 2, 2, 2, 2, 2, and 2. If I multiply all this, I will get 2 to the power of 6. So the answer is 1, 2, 3, 4, 5, 6. 2 to the power of 6. So these are the number of ways I could answer 6 questions, okay, by using this method. Let's move on. Now we're going to look at another similar problem that we can use the same method. What if there are 3 person A, person B, and person C? If they were to stand in a row, how many ways can they be arranged? Now, using the method that we learned just now, let's try to figure this out. Now, the first person on the row, I have 3 choices. Okay, I have 3 choices here. I got 3 people here, 3 people here. So the person standing at the front of the row, there are 3 ways, because I can choose from 3 people. Now, once I've chosen one person, let's say A, I have 2 person left. On the second row, there's 2 ways. And on the last row, I have only 1 way. Now, if I were to multiply this, I will get there are 6 ways. Now, I can check this if I want to, okay, by doing the regular method that I learned. Okay, what I could do is I can start listing them down. A, B, C. A, C, B. Okay, and I can keep going, okay, until I flip them over to the other side, and I will still get 6 ways. Okay, so maybe you can use this listing method or a tree method to confirm whether this is the answer. Now let's go back to what we talked about, multiple choice questions. Can I also figure questions like this in the same manner? Yes. Let's say I have 7 questions. And each question has 5 choices: A, B, C, D, and E. 5 choices. Now, if you go back to the first problem that we tackled, which was the one on true or false, it's pretty similar. Okay, now again, I can just draw this box. I have 7 columns. Now each question, there are 5 ways. Okay, I can select A, B, C, D, or E. Again, again, again. okay, because each has, and then I just gotta multiply all these numbers, and I will get 5 to the power of 7. These are the number of ways that I could answer 7 questions. If I do not know the answer and I just pick them randomly, they are 5 to the power of 7 ways. So as you can see, we can use listing. We can also use tree diagrams, but when the numbers get big or when there are many choices, this turns out to be a better way to figure out how many ways, whether I can answer the questions or how many ways can I arrange people in a row. Let's move on. Back to the problem that I posed earlier on, which was about the passcode of an iPad. Now you're allowed to enter a 4-digit passcode given 10 digits. So how many passwords is that possible that I can enter? Okay, to again, to enter this problem, we use the box, okay, method that we have learned. So again, just draw a nice box here. It's a 4 passcode. Okay, so assuming that I can use all 10 digits, so I can enter 10 digits here. Now again, I can use the same 10 numbers again. It's not that I cannot use one of those numbers. So again, there's another 10 possibilities, another 10 possibilities, and another 10 possibilities. Now this based on assumption that I can start with a 0 and I can repeat these digits 0 0 0 0. In some cases you're not allowed to start with a 0, but assuming in this case you are allowed. So if I were to multiply this, I will get 10,000 possible passcodes. Now if you think about it, 10,000 different combinations, is this a really large number? Will that make my iPad easy to be hacked? Now again, this 10,000, though it looks like a lot, if you were to manually enter each possible combinations, so there are 10,000 of them. Now, but I could easily write a program that could easily check all these 10,000 possible combinations in, like, you know, really quick. I'm talking about less than 1 second. I could figure out the right passcode to hack this. Okay, so again, I mean, in basic counting theory, sometimes we are interested in problems like this because we want to know, in this case, whether an iPad passcode that we enter at the beginning, a 4-digit passcode, is it secure? Now the answer is simply no. Okay, so these are the kind of questions that we can use basic counting theory to answer. Now we've looked at some basic methods of doing some counting, and in particular we have learned the method of using these boxes in a row. Okay, and then we can just enter the right numbers based on the problems, and then we can easily and quickly count the answers that we need, instead of doing a list, or which may be too long, or even for that matter of fact a tree diagram. The tree will be too big. Okay, so we've learned some basic counting theory, and we will proceed to the next video where we will try answering some problems using the techniques that we have learned thus far. Thank you. See you then.